Okay, it does say gallery. Hey, who joined the meeting first? Was it Dylan or Robert?
I'm pretty sure it's Dylan because I just got here.
Hey,
Hey, yeah.
Dylan. Hey, so what does it say when you go to the view menu in Zoom? You know, the top right when it says Zoom. Does it say gallery or
Like by default?
Yeah.
By default, it's on speaker view.
I think that's what it is. Okay, so I've been trying to figure out why when I record in the cloud, it's not consistently gallery. It's sometimes a speaker view, and most of the time it's speaker view actually. And I couldn't find a setting here in the meeting when I join as guest, and I couldn't find it in the meeting setup either in the configuration properties of Zoom. So I was trying to figure out what might be the case, and I think this is what it is. The first person to join the meeting, I think in this case I think you have to set it to gallery. So if you set it to gallery, if you don't mind, set it to gallery. So then all of us should be visible on screen. Yeah.
Yeah.
Okay. So let's see. When we get the recording, we'll find out because next.
Okay.
Then we'll know if that's what's going on. Zoom is just using the random setting of the first person to join the meeting. Yeah,
That's interesting.
Yeah, because if you find out a way in which I can because if you look at all the recordings, they're all, a lot of you attend, but I'm not able to see who attended unless they're actually speaking up, because only the active speaker is in view. And it's much better with everybody, in here rather than just one person. So I see if you can get it to gallery. Yeah, I think that'll be cool. In fact, it'll be better if we just, all of us just have it in gallery all the time so that we all can see everybody. That'd be fun.
Yeah, I'm surprised there's not a setting in the Zoom, like your setup for Zoom.
Yeah, no, I think it's individual. For each person, they can select whether it can be gallery or speaker.
That's interesting.
Yeah. Hey, anyway, great, John, welcome. And so again, I just stopped by. I think Namrata had a question, and you guys were discussing, on the Reddit. I figured it's easier to just talk about it here than to type up something, and then like doctors and professors have the liberty of doing is, all right, now I explained it. Now one of you can summarize in the forums now, and I think that'll be cool also. I can do that. So, but I've forgotten the question. Let me just maximize this window, and then one of you can. I think it'll just come back to me as soon as you start describing what the thing is. So what is it about? It's about hash tables, right? No, you are in 2B. So it's tries versus hash tables. Tries versus hash tables. Okay. Yeah. Okay, all right. So do you guys want me to talk about it? I can talk about it now, or if you want to talk about it first and then I can come back later, that's fine too. You just want me to talk about the differences, and because that's that question in the spec that says, if you wanted to store all the prefixes, if you want to store if you want to duplicate the function, right, of the prefix tree, which is a try, using a hash table. Is it possible? Well, it is possible, obviously, yes, because you have a key and then you can for every key. However, it is not just inefficient, it is actually horribly inefficient, because it is what we're doing there is we're taking two things where functionalities are completely different. The try is meant for prefix searching. That is why it is structured in this particular. I'll go. You'll know exactly what the what it means, right? So soon, hopefully, right? And I'll answer all the questions. It is a structure that is designed specifically for traversing prefixes of known words, fragments that you have in the language, and for that it does magic. Okay, it's because it's really constant time. If you give it a string, it can find out whether the string exists or not in constant time, regardless of the number of entries already in the try. Yes, because all you have to do in a try is you got a string, right? And then even if you have 1,000,000 strings in the try, a trillion strings in the try loaded already, the try is really huge, right? But an input string only has n characters. let's not say n, okay, because n is a size of typically, right, in computer science, say n is the size of the data. So if that'd be like a trillion in this case. So let's not use n. Let's just use s. No, s is a string. Let's k. All right, k is the length of the string that you're trying to see if is this k length string in the trie or not. Okay, and the beauty of the trie is that it can do that by traversing the trie in time that is not related to the number of elements in the trie. It's the fact that it has a trillion or billion or countless elements doesn't matter, because all that is required is just s k indirections as well. Right? It's there. It's I think the term for it is indirections. Basically, k times you have to follow through the pointer, because you got the first letter. The first letter tells you, all right, it's not a null pointer. That means it has a continuation. Yeah. And then you can look at all the continuations, but you only got one that matches them, right? So let's say, sometimes, right? And then you go down O. So basically you traverse one letter at a time. And you essentially touch each letter one time. So and it's independent of the size of the trie. Now, suppose that, and the beauty here is that the space complexity is extremely low here, because you're only storing each letter in a word one time, as compared to if you wanted the same functionality using a hash table. Okay, right? If you wanted that, first of all, because it's apples to oranges, if you wanted to do that in a hash table, it is going to be horribly bad and inefficient, as you will yourself tell me. Okay, the only way I can do that is for each prefix. I don't have one possible descendant. I have many descendants. Like for some, a prefix called some, I could have someone, somewhere, someplace. Yeah. So I could have many possible postfixes for a given prefix. So if I want to store a hash table, unfortunately, you guys haven't covered hash tables, but I think some of you are familiar with Python and all, right? Because you have dictionaries in Python. Yeah. This is a hash table is just is a dictionary. So, but if you want to use a dictionary for this, you'd use a key, which is sum, but sum does not map to one guy anymore, right? Sum maps to like 5 different words that can follow it. Somewhere, sometime, someplace, yeah, someone, many of these. So it's not enough to have one key and one value, both strings. You got to have a key that is a string, yeah, but the value has got to be a set data type of pointers to strings. Right? Now, technically, you can actually have strings then in C++, because if you have a string data type in C++, I don't even know if this is necessary for 2B level, but I think you'll appreciate it, because you guys are now, and Shirley is a hardware person. She'll see where this is going and all, right? See, if you have a string in C++, it is an intelligent object. Unlike a C string is basically an array of characters. That's all. Yeah. So, an array of bytes, that's your C string, terminated with a null character, 0 byte. That's your C string. But a C++ string is actually an intelligent thing, because it has a lot of methods attached to it, like find, erase, and all those things, which. But the thing is, lots of people don't, especially Python programmers and other programmers, they don't realize the cost of these things. So they might do a find, which is actually linear in the length of the string, right? And do an erase in the head of the string, which means all the characters have to be shifted backwards and all. They do that. It's possible, but it's done with heavy, huge cost. But let's not go down that road. But what would happen is that time follows sum, but the same string follows many other words, many other prefixes too, right? Anytime, for example, right? For any two. So the same string occurs in many places. So if you want to use a hash table, so you got to have a key, which is a string, and then the value is going to be a set data type, which has a lot of pointers to strings. And you want to have pointers because you want to store the actual string only one time in memory, but only store the pointers to them. So you have a long string. You don't have to replicate it many places. You say, well, this long string follows these many different prefixes. So you only have pointers to that guy. Yeah. In fact, when you go to 2C, the very first quest gets you, in the mindset for appreciating that kind of thing, because you will be actually looking at situations where you store, what do we call them? Blobs. Yeah, I think the term out there is called blob, binary large object. I don't know what the B stands for, right? It's called a blob. Okay, a binary large object, meaning I don't know what the hell it is. It's just a binary file. right? So it's a huge, and it could be gigabytes and so on and so forth, like a movie and all. So and in data structures, where you have the same movie occurring 5 or 6 times in your data structure, it's not feasible to have so many copies of a large movie. So you store it in one place, but you store a pointer to it in many places. Yes. So that you'll be doing that in quest number 1 of CS2C when you get to that. But that is essentially what it is, right? In a hash table, if you want to use that, you're going to have a string for a particular postfix, but all the guys will have to point to that guy. Now, if you want to do it in C++, in C, you'd have to do it yourself, but in C++, I think, so maybe some of you can do some research and verify this. In C, you can just use a string object, and even if you have duplicates of that, it doesn't matter, because string is an intelligent guy in C++. If it's the same string, it knows this string is being referred to by 5 million different places, so I'm not going to release that until all of the references are gone. So it keeps a reference count. So you don't have to explicitly manage, I got a pointer to, Hendrickson. So I got Dylan points to Hendrickson, and other, right? Your mom, dad, all of those people point to the same. So it won't do that. And I think, so that is the advantage of using a string. I think that's what goes on, okay? Because it does that pointer manipulation automatically for you, which is kind of really cool. Because, and in Java and all, see, this thing is, in a C string, because it keeps that reference count, it knows immediately when the reference count goes to 0, it can let go of it. Yeah. Because every time you create an access point to it, it's going to just increment the reference count. But languages like Java and Python, it's more expensive, because it's not, it's not like triggered off by, it's not like triggered off by an alarm, essentially, because the reference count went to 0, bam, memory's gone. Yeah. So it's deterministic and predictable, bam, like that. But Java and Python, it's not like that. Okay, it's the reference count goes to 0, it just goes and sits somewhere in random heapy places, waiting for someone to come by. Garbage collector kicks in random times when you don't expect it. At the least expected, the garbage collector kicks in, like the Spanish Inquisition, right? And just decides, I'm going to clean up your memory now, and all these little integers. And see, that's the thing, in C and C++, you don't have to say, I want an integer object. You can say, I want a raw integer, and it's on stack. But everything is on heap, and you got to do these memory things. You got to be a really, really good computer scientist in order to write Java code and Python code, right? Because, even beginners can write Java code and Python code, but only good computer scientists can write good Java code and good Python code. Ordinary code in the more sophisticated languages, it doesn't get you far. And I think that's my opinion, because otherwise, I've seen code written by really good programmers in Java, as well as newbies, and that's why it's, when you're in a software engineering out there, it's good to be it's good to have either a manager or senior workers who've had many years of Java or computer science behind them, and just follow them, because a lot of this you just learn by watching and experience. And practice doing that repeatedly, and saying, hey, why did they do that? I could have done it this way. And you ask them the next morning, rather than Google around and go down 100 different rabbit trails, rabbit holes. So that's what's hugely important. And so in Java, that's why it's very easy to get sucked, and Python too. It's very easy to get sucked into bad code written by bad engineers, not bad engineers, untrained computer scientists, because they will be doing the job, because the languages are so powerful that you can tell them to do it and they'll do it, right? They're not going to tell you, it's going to take quadratic time versus linear time. If you could do this in log linear time or logarithmic time, right? Binary search. But if it's not sorted, and it'll just do it inefficiently because you told it to do it. It's not intelligent, right? It'll all be different in a few years. But right now, I think that if you look at bad code and follow bad code and bad examples and bad people who don't know what the hell they're doing, then you'll think that's what's done, because that guy is a senior to me. They wrote code and it's been deployed out there, and millions of people are using it right now. And then that kind of deference kicks in. I think that's one of the more important things. Okay, whether you're doing your own company or working for other people, it is like super duper important that your manager is actually a competent person. Okay, and I think the reason I say is this is a lot. You can do a lot of stuff just incompetent. You can look at it, right? There are lots of incompetent people who can make a decent amount of money, and they're happy too. right? But the thing is, what happens with competent? But the thing is, once you get competent at something, like you are a master of the C++ thing, or you know how to use these libraries, you actually know what the hell is going on. The CPU does at any instant of time. Then, if you have an incompetent manager, when they force you to do something that is obviously incorrect, and for reasons that are not justifiable rationally, right? So this is the best way to do it, right? And those kinds of things I've found that the competent engineers really take exception to, right? You see, I would not do this at all. I would never do this, right? Because that is not the right way to do it. And whereas incompetent, no, not yet competent, let me say, not yet competent means they'll just say, okay, well, you know what? I don't know better than that person. I'll just do it the way they do, say, yeah. Or they say, or if you challenge them and say that's not the way to do it, they may ask you, right now, what do you think is a better way to do it? And then I'm going to be stuck. So I better just do what they tell me. And so that is why it is really good to get. And the other reason why, if you're starting a company, to make sure that only competent people are managers, is that when a person really knows their shit, they will not hire other people under them who are ignorant, right? They should know what the hell is going on. However, if the situation was reversed, okay, if that person doesn't know what the hell they're doing, they're never ever going to get someone who's really good to report to them. First of all, that person is not going to report to them, so there will be authority issues, and there'll be rebellion and saying what do they call it, authority, resistance and all that kind of thing, because and so you'll feel really bad working for that person. But also that person feels a threat because you can do things much better, and maybe you complete in 1 hour what other people are taking like 2 days to do. And then this person might feel guilty that maybe that because they don't know that you actually solved it with a brain stroke, really insight like that. They might say because they didn't understand the details of how you did it. They might say, well, you don't have enough work to do. You only had 2 hours worth of work, whereas that person had 2 days worth of work. Whereas you actually finished the 2 days worth of work in 2 days, 2 hours of time. Those kinds of things will only be visible to a really A player. That's right. If you get an A player. You can be so this guy is going to be a threat, and they will not be able to advance, and they'll be made frustrated, and they'll leave. So if you're starting a company, first thing to do ever, right, later on, because I'm going to retire next year, right? So maybe you'll start companies even after that, and make sure that first of all you are really good in what the hell you're trying to do. Okay, if you're trying to do something in software, you need to get a solid intuition about what the hell is going on. And you need to know, right? Oh, well, is log linear, can I shave off this constant factor here? Okay, you'll get to do that in CS2C. Even though both of them are log linear algorithms, one is faster than the other. Sometimes you even prefer a quadratic algorithm to a log linear algorithm, right? And why is it? Because we've done these so many times that we even figured out that, okay, well, the constant factors are now we have more control over that. So when you tweak the constant factors like this, the quadratic algorithm is actually better on average than the log linear algorithm. Log linear is better than, graphically log linear is better than quadratic, isn't it? The parabola and the log linear kind of tapers off like that. So and so those are kinds of things that you look at and say, well, and you'll get an intuition about these. And that's the important thing. Okay, just following the rules or implementing algorithms by the book, buying these textbooks and implementing the algorithm. I used to have this big book called Numerical Recipes. It was really good as a research student. It was good because it had a lot of really nice and powerful algorithms in C++, including matrix multiplication, which you're going to be coding, by the way, next if you're in CS2C. And I used to do that, I think, but then after you start working and all, it starts getting more cumbersome looking up the algorithm and implementing it again, because you leave your code behind and all these things you don't tend to remember. And then you kind of figure out that why don't I just do it myself? Because I'm just going to type it in, and you realize that well, I don't know, maybe it's not generally the case, but I realized in my own case, at one point I was typing in an algorithm, and I realized, why the hell am I typing it in? Because I know what to do, because I've done that so many times before already, and I know what to do, and why should I type it in? And you just get to that place, I think, and you say, well, you don't need the book anymore, you just type it in. And you can follow the logic and say, well, it's right or not. And I think that is how I think it works eventually. Once you soak in it for a long time, it's not going to happen anytime because, you guys are young enough. So I don't think you had that much of an exposure to the, well, you got to soak in it like marinade, like tofu for a long, long time. And then it just clicks all of a sudden. You just know, and it's not like you wake up one morning and but you just know at one point, right? Last year, I didn't know, right? Last year, I didn't have a sense for how this happens. But this year, I totally know how it happens because now, now anyone can wake me up in the middle of my sleep, right? At 2 a.m., 3 a.m. and say, can you teach me max flow or Kruskal's algorithm, right? All I need to have is just a whiteboard and I'll just start teaching right away because I know how it works. Yeah, and it just, you don't have to look at a book anymore. And I think, right, and you do have to look at a book sometimes when you say, well, you know what, you want to, this is the way to do it, but let's look at the detail of how that person is particular, that particular solution has been done because it's supposed to be elegant and all. You start looking at things for aesthetics and to cut corners, right? Not to cut corners in a bad way, but to say, is this the best that can be done? Maybe that person has done it better because they've done really, really cool algorithms that's been published before. So you'll start looking for those kinds of things rather than how to do it. Right. I think that is when you'll catch yourself, I think, saying that, well, you know what, I'm not looking for how to do it anymore. I'm actually looking for how to do it better. Yeah, because they're both research, but you're looking for how to do it better because you already know how to do it. Sure. And I think maybe does a PhD train you to do that? There is this part, at least, it's called literature research, literature review. I don't know what they call it here. Back in India, I think it's called literature review. It's 1 year when you are not expected to do your own research at all. It's the first year, and all you have to do is just look at what other people have done and study them. It's called, I think it's called literature review. And then at the end of your own research, you have to say, hey, these are all the other ways of doing it, but here is one small tweak, adding 1 to an integer, right? Improves the best known number by 0.01%. And that's my PhD thesis, okay? So because, so much work is done in all of these things, no matter what, it takes a huge stroke of luck to get a huge win. But most of the time, a moderate win is actually enough to make most of us happy, really, really happy. Because you now know the lay of the land, right? Because in order to get the moderate win, you know the lay of the land. Otherwise, you don't know it's a moderate win, right? Because this is the best people can do, but I'm actually one tiny bit better. And you'll never get that satisfaction until you know what's possible. So that's usually what happens, I think, in PhDs. Yeah. But it's all strange. It's all personal, I think, and it changes from person to person. My own PhD experience is very, very different. I think from many other people. I switched advisors and so on. But it is all fun, and at the same time, I didn't know proper research after I finished PhD. PhD is supposed to be training to do research, and that's what it is. Okay, a PhD is not a degree. What a PhD is, I think, is here is a recognition that this person does not need to be a student anymore because they have now proved that they can learn by themselves. That is what PhD means. PhD means you have now proved your ability to teach yourself, do research on your own without guidance from someone else. Okay, and in my own case, and I think in some other people that I know also, it didn't happen after when they give you the degree. It didn't happen at all. Totally not. I had to work after that for many years before I realized that, okay, well, you know what, getting that piece of paper was actually nothing at all. I didn't know how to do research. I didn't know what to look for, and what to look for, I think only takes, I think the 10,000 hour rule. 4 years is not 10,000 hours, certainly, right? Not for a PhD student. So after 10,000 hours, you just wake up. It's different now. So, but you have to keep at it, okay? Actually, yes, and I will be making this point more forcefully in my 2A class in fall, because there's going to be 2A, students, but they'll be in the evening section. But certainly, save all your time watching, playing Fortnite, Netflix, and all these entertainment things. Just think about it, okay? Think about it, because this is like super duper valuable time in your life. Okay, every hour you spend on improving yourself and learning a skill will pay back like 1,000,000 times later. Okay, and there's a huge amount of demand for your time, and for which you're being made to believe that you're paying for someone else to use your time. Okay, you're paying Netflix to take up your time watching a movie, right? Unless you're planning to be a producer or something, you know, write the next kick-ass novel or make the next movie and all. Just reel it in. Say, all right, only 2 hours of entertainment, Fortnite included, because I know many brilliant minds have totally been wasted by Fortnite. Okay, I know personally, lots of people, not totally wasted. You know, they'll come back and do things, but yeah, I can see it right in front of my eyes. They're wasting away like a gold in their time because they're so intelligent. They're capable of doing great things, which is, you know, and Fortnite is just eating up their time, like, you know, 5 hours a day and all like that. And that seems to me like if I'd done 5 hours a day on a game when I was that age, there are so many things that I would have totally missed out on that I know now. Thank goodness I didn't have Fortnite, because those things now, if I want to learn them now, it's much greater of a sacrifice for me, right? So maybe I won't even learn them because now, but that time it was so easy for me. So yeah, don't let you know, these other, and the other thing that I think I already mentioned maybe to my 2C students is also let go of the temptation to enroll in many different courses and excel in everything. And I think that is a temptation, especially in the Bay Area. And I will say that in the fall quarter too, is that lots of students enroll in hardcore science courses, like, you know, computer science, math, and things like that. Take a lot of time, exposure. You got to really soak in it. Takes a lot of time. Okay, but at the same time, strangely enough, they say, I also want to enroll in art, or not for the purpose of entertainment or, you know, relaxation, which is different, because then you're not bothered so much about the grade. You just want to go and make a pot, you know, or paint something and have a good time and unwind. But here, the focus is more on, I got to spend so many hours because otherwise I wouldn't get an A in English or history or art and things like that. And they're not professional courses. I think personally that they are better reserved for a time when you've taken the core courses that are going to guarantee you a good life. Okay, they are in place first, and then you have a lot of money and time on your hands. Now you can do all of the other courses you want as much as you want. But I think that is a better balance, because and the reason I say that is because in my classes, I find a lot of people who are capable of a lot of things. Okay, they do great work when they're engaged and they're doing work, but then all of a sudden they disappear. And then I talk to some other people and I find out that it's not because of, they're also enrolled in a whole lot of other courses, not just directly in STEM. They're related, you know, in all, you know, history and things like that, and so on. So you don't have to get an A in everything, but they're trying to get an A in everything, and each one is time consuming. So I don't get, computer science doesn't get its due, and it's a professional course. It needs a lot of time, and so take all the time you have and put it in computer science, and then later on it will just make all the time you want to do whatever the hell you want for the rest of your life. All right, so it didn't mean to sound so preachy and all, but I right, but I do think that a lot of you have a lot of potential. Okay, a lot of potential, and I'm very happy, you know, even though only 6 of you were turned up. I'm very happy that you're raising all these interesting questions on Reddit, creating all these kick-ass discussions. Hopefully I answered the question now, right? Because Namrata, the hash table is horribly inefficient, doesn't it? Because it has to store many pointers and so on. So for each sum, and then it has to have, yeah. So it's a pain. It's a pain. It's possible, but it's a pain. And yeah, again, but someone who doesn't know computer science may do it with a hash table. And a manager who doesn't know computer science is likely to say, great, we got something done. It just takes a lot of money. Yeah, and they get, you know, approval from the business department, who haven't the faintest clue what the hell happens in computer science. And they buy a big ass computer to do something that you can do on a laptop. Yeah, so these are things that you can avoid happening if you're a technically minded CEO of a company, right? So your own product, you know exactly what the hell is going on to the last detail, because so many ways that you can do stuff badly that most people don't even know. Right? Even now, when I, you know, do a transaction on my phone, I bet that, you know, in order for my transaction to register, like 10 or 15 chain events have to happen before it, you know, happens and my bank is debited. I bet that at least a couple of them are totally inefficient. Right? They happen. So, you know, it all works out in the end. But I bet there's so much inefficiency everywhere. So if you really set your mind to it, you can clean up things a great deal. And obviously there's a lot of money to be made in that, but you don't have to do it for the money. It's actually fun to just, right? When you're ironing clothes, when it's got a wrinkle in it, even though it doesn't really matter because the wrinkle is in a place that you don't even see, instinctively you iron it. It makes you feel better because the wrinkle is gone. Yes, it's like creases in software, and inefficiencies everywhere. And inefficiency somewhere is basically a wrinkle in space-time. Okay, it's just got to be smooth and no events. Okay, and calm and peaceful, and then we're happy. And I think that is why you'll actually feel a sense of satisfaction every time you just get rid of an inefficiency and make sure things happen automatically. Like, when I purchase something, it just happen like that, bam, like that, like Bitcoin. Or, even Bitcoin takes a long time because it has to check all those signatures and so on. Many times it doesn't validate, but lots of these things can happen instantaneously. But it's because of inefficiency, and we have to account for the inefficiencies, right? When you're designing a large system, you can't assume that every module is 100% efficient, right? So you automatically assume that, well, let's say 10% of the modules are inefficient, and this, so you can't assume the best possible route every single time, but you'll establish that, and then eventually, just like a graph algorithm, right? You establish, okay, this goes to the destination, the source to destination. Now let's see if there's a better way to do it, right? This segment, instead of going this way, it can go like that. Okay, so I've reduced the cost. And so you can do that and get the most efficient route to the target. Right, so one of the algorithms that you can use in a graph route finding algorithm. So just like that, I think. I don't know how we got started talking about that. Anyway, I didn't mean to take up so much of your time. All right, okay. So unless you have any questions for me, I'm very good. Hey, yeah, okay. Actually, so now you're coming up to question number 9. Yeah, question number 9. Okay, so I have an idea. Maybe, yeah, by the way, you should not restrict yourself to just generating one pretty picture. Okay, so when people do question number 9, they generate these pictures and share them on Reddit. It's actually a lot of fun. And don't restrict yourself to just one. Do as many as you want. And then maybe I'm thinking maybe next quarter or so on. Already I got one from Zach Minshaw. Okay, that was several quarters ago. And he made a picture of an icosahedron. Okay, it was actually 3-dimensional in size, in shape. You can rotate it and all with your mouse on the screen when it appears. But then that got me thinking, well, you can do other 3D shapes too. So maybe you can try that. So one of the things you can try in a graph when you get to it, number, I think that's the next one for you. Yeah, most of you who are on Quest 8. So do a cube or in a cube where 1 A B C D. And then E, F, G, H behind it. So 1, 2, 3, 4, 5, 6, 7, 8, 8 vertices, and then draw lines like that, and then lines like that, and then connect up these guys. Okay. And I think, if I'm not mistaken, that might actually show up as a cube that you can rotate with your mouse. I don't know. I've never tried it, and it'll be fun to see if one of you can try it. And I'm thinking maybe for next quarter onwards, or maybe fall. When for the last quest, I won't just put up the millipede thing, which is from me. Now I alternate that with Zach's icosahedron, but maybe I can start picking a random one from a past student. Yeah, and say, hey, this one is from Namrata, Sp23. That one's with Dylan, Shirley. And so, different people's pictures can also, not pictures of, face pictures, but the graph. Yeah, the graphs that you produce. Because some of them are really pretty. I was totally surprised. Some of them, Divyani produced a really, really nice butterfly last quarter. I thought was, it was incredible. It just came up like that. Didn't even have to be. Sometimes the pictures are there, and then you have to use the mouse to unjumble the nodes a little bit to, push them around. It's locked into place and all. But that one, just as soon as I fired it up, bam, it showed up without any tangling anywhere. It was a full-fledged butterfly. Very nice. Anyway, have a go. You got a lot of time to play around now. Since you're on Quest 8, most of you. I think you have a lot of time. And the final is not going to be like super duper challenging and all. Okay, just like it's going to be like your midterm, and I think you don't have to get stressed out over your final. It's just like two more weeks. This is week 9 starting on Monday. Week 10 starting on Monday. Yeah, week 10. So 2 more weeks of classes. So yeah, obviously I'll see you next week also. But certainly if I don't. You don't have to worry about the final, okay? I think you, and we'll also say you can send me corrections for the top 2 questions you missed or something like that. and then I can put back the reinstate the response. But take your time and going through all the quests, getting all the eking out all of the points you can, and also try and produce some really nice, cool pictures. And also your final report. Okay, final report, and write it in such a way that it's also a bit of an advice for future students in the final report, saying here's what you can expect and how much work you can do and so on and so forth. So we don't have people jumping in with wrong expectations. It usually is the case, right? When we started the class, we had like 40 enrolled students, yeah, and then the first couple of weeks, a lot of students drop, and it's not good for Foothill, first of all, okay, because this class is usually unproductive class, from Foothill's perspective, in a sense, not you guys, the class, meaning I'm only teaching for 25 students or so, when I could potentially be teaching a lot more, yeah? So it's as an investment vehicle for Foothill, it's not a good idea. And besides, it's also bad for the students themselves, because they don't know how much work there is, and they go and join, and they got to make plans later on. So you can write this as advice for future students also in your final report, and I'll link to it in the syllabus. I'll link to it in the syllabus, saying read this before you enroll. Hopefully my future enrollments will stick on and not just drop off like after the first couple of weeks. All right, unless you have any questions for me, I'm going to take off, and then you guys can
Professor, when
Yeah,
are
sure.
you doing 2C next?
No, I'm not. No, unless the department requests me to, I'm not going to, because I'm not.
Okay.
My 2A and 2B are my full, focus from now on. Because otherwise, if I let go of 2A, I think there's a lot of downstream problems. I started to focus on 2B and 2C more, and then I found that all of my 2B students were crappy. So then I said, okay, now let me not focus on 2C, because when they do a good 2A and 2B, they can teach themselves 2C for sure. I'm pretty sure, right? Right now, none of you guys have to enroll in my 2C. Really, you only have to do it if you want to do. After you finish Quest 9, you don't really have to do my 2C unless you are in it for the credits, okay, transcript. Because I'm confident that you don't have any problems in your own time. You can just do it. All the red quests and read all the modules, they're public, yeah, and follow that, and you can even participate in the Reddit. Who cares, right? Who knows anyway, right? You can participate in the Reddit just like a regular student. Reddit's open, not just for Foothill students, so everything is possible. If you you should absolutely be able to do that. If you don't want to do 2C, certainly that's, so I decided to focus more on 2A now. And then you don't have to do 2B if you don't want to, but if you do want to, you're out. Obviously, if you got more than five people who want to do 2C stuff, I'm just happy to teach on Saturdays and Sundays, 1 hour like this, outside of Foothill. But it's got to be 5 dedicated people on Zoom, and I can teach 2C. And it doesn't have to be 12 weeks either. I can do it at any pace that you guys are able to do it. So it doesn't have to be a formal class unless you need the transcript.
Okay, thanks.
Awesome. No questions? I'll talk to you guys later, okay?
All right, see ya.
Bye.
Thank you.
Okay. So I'm ashamed to say this, but I'm kind of stuck on the second mini quest.
For
I'm
which one?
just like the insert function. It's just like the end of a string, I think. I've been reading up on it, but mostly what I see is like Boolean like they just use Booleans as to declare as the end of the string. I don't know.
Pull that up.
This is for the insert.
Yeah.
Did you say, what did you mean about
Class
the booleans for the end of the string?
The /0.
I don't think that's necessarily a boolean. It's just It's just like a special character that they have.
Yeah,
Like it's
it's
kind
a
of like the
char.
/n. Yeah.
Yeah, I've been trying to figure out how to approach it. Like I understand that I use cur.next, but like after that it's like I'm unable to fully realize what I'm trying to figure. Like the so I tried making it equal to the char, but I know that's not gonna work. Like that's just one thing that I tried. I tried different functions pertaining to vector, but that also didn't seem to work. So I'm kind of lost here.
Are you following the professor's like the he gave like a little bit of like the
Yeah, the
blurred out
code.
code? Oh,
Yeah,
okay.
the little blurred
So,
out part.
or like the last part about the /n.
Yeah, this last 0.
Oh yeah, /0.
It's a 0, right? Yeah, yeah, just slashing it. Yeah, I've been just trying to figure that out. So I know it's supposed to be like the last part of the string, like /0, the char, but and I know I'm supposed to like I guess like set what are like in the vector as that, basically like that at the end of like the um for loop, I'll set that to the /0 or something like that. I'll set that to /0, but I'm not really sure how that's supposed to work, if that makes sense. Because I know like it you're passing in char values into the brackets in the array, but after that it's I'm not really sure.
For me, the thing that really helped me understand how I would insert something into the tree, or into this node structure, since this is a node function,
Yeah.
was to just draw out what it would look like for the word that you're inserting. If it's like yes or something, your root would be pointing to a bunch of a vector of all of the possible characters, and the only one that would be sort of lit up would be the y, and then that would point to a new vector of all of these possible characters, and on that vector the only one that would be lit up would be the e, and so on and so forth till you get to the end. The s would point to another vector, and the only thing that would be lit up would be the null character, the \0. So when you look at that representation of what it looks like, then it should be a little bit easier to like visualize, to sort of work backwards. Like, okay, if I'm starting with just a node that has a vector that's empty, that has nothing in it, what are the steps that I need to take to populate this diagram that I've just drawn?
Okay.
But
So
essentially, all you're just going to be doing is like, I mean, you know how to iterate through a string. You're just going
yeah,
to be using like the bracket I or whatever, and you're getting your character, and you're operating on each character, uh, deciding if you need to insert it in a place, or if that spot is already lit up, then you don't need to insert it because it already exists there. Uh, then you just sort of set your pointer to be that one that's lit up, or you set it to be a new node if it wasn't already lit up. and then you just sort of progress along through the diagram. It shouldn't be too long. Mine is like 18 lines long.
Your if statement for that?
That whole function.
Yeah, the whole function. I was like, that's a long Okay. So I guess there's more to do in the if statement. That's what I'm guessing, at least for the insertion.
Yeah,
Alright,
mine is like, I have a for loop that's basically all that's doing is just looping through the characters of the string. That's like the outer structure, because you have to look at each character of the string. And then the inner structure is just a couple if statements, if else, no, two if statements and an else statement that sort of decide what you do depending on the state of the node that you're at, whether or not its vector has certain things, already inserted into it or not. You're pretty much just checking if this is the character, let me look and see if that spot in the vector already exists. And if it does already exist, then I don't need to insert anything because it's already there. So I'll just set my pointer to be that spot and move on iteratively to the next node.
yeah. That's what my for statement, my for loop is doing, but it's just afterwards, like in the if statement. Because okay, so what I'm doing is I am looping through like a string, the string that's inputted, and I'm saying that to a char, and then I'm deciding if it already exists or if it needs to be resized, like the vector, or if it's an empty vector. After that, I either detect if it's a null pointer, and then I set that to a new node, or I guess I'm not really sure.
It sounds like you're totally on the right track.
Yeah,
Um, I personally, I didn't use a char. I used a size T because really you're using the underlying integer representation of the char. Like the \0 is 0 in your ASCII table, and so on and so forth. A equals some number or whatever, and the vector is mapped that same way. So I've found it easier to just save the character of the string as a number instead, the number that it would be in the vector, if that makes sense. So then I could just say, does this number already have something at that spot in the vector? But I'm sure you could do it as a char too. I don't think it would functionally be very different.
yeah.
But I
I'm just
think in
like,
the specs, he talks about like 3 different things that you need to check each time you get a character. You need to check if the vector is too small, if there's nothing in that spot, and that's pretty much it. If there is or if there isn't something in that spot. Those are the 3
okay,
things you're checking for.
but yeah, all I've been getting is like a pointer exception error, so I'm not really sure.
Make sure you're checking that the size of the vector is the right size first before you try to index into it or something. See you later, Jonathan.
Jonathan?
Yeah, he had
Yeah,
wave.
um,
Yeah, make sure the vector is the right size first, because if you're trying to index into a vector that's too small, then that would throw up
maybe
some
that's
kind
it.
of error.
Yeah, if you're
Yeah,
following the template code that he gives, like the last 2 outside of the 4, those if statements are like for those like edge cases where the next vector is either like it's too small or it's like it's like null pointers. So you'll be checking like I guess I don't know if like you need to do it at the end, or you could probably do it at the beginning too, but it's just I think if you account for those cases somewhere in your code, then you should be fine if you're doing the for with those cases.
Yeah, maybe that's what I need to do because, yeah. All right, I'll check the vector length, the vector size, and make sure that the char isn't too whatever string I'm doing is too big for it. I guess that's what I should have been doing.
Yeah, because your default state for the node, the vector is empty. It doesn't have anything. And so you get your character and it's whatever A or whatever.
Your
And that's got
base,
some number that you're going to put it into that spot in the vector. So you need to resize your vector based on the character that's being put into it. Or you might not.
yeah.
The vector might already be big enough and then you don't have to resize the vector.
So I'm guessing I've basically been having a vector without any size. That's basically
Yeah,
why I'm
probably.
getting. Yeah. All right, I'll look into that.
Namrata, where are you at?
Oh, I'm at like it's like this like lounge for this like door building.
It's like you're in a hospital or something.
Yeah, no, it's just like it's like a building lounge.
Shirley, we can't hear you if you're. Yeah. No. It doesn't look like you're muted, but
Maybe your microphone volume might be low or something.
yeah, do you have a microphone plugged in? Not good enough at reading lips for this. Oh no.
Maybe you need to read her mind. I think that's it. You see, I'm not there. You just have to imagine that I'm there.
Namrata, have you started on Quest 9 yet?
I've read through the specs a little bit, but I haven't actually like started coding it.
Yeah, I'm like
I will.
kind of
My
overwhelmed by the
school
lack
actually
of
has.
specs.
You're what?
I'm kind of overwhelmed by like the lack of specs.
Yeah, I know.
What to do. He was talking about like you should be able to like move it with your mouse. I don't know.
I think that's maybe in the
Okay.
question site.
I
It
fixed the
might
no.
come up.
I fixed the no.
Okay.
And like how like it'll like show up when we see the test output, and like we might I don't know, maybe.
Okay. Maybe.
I guess
maybe.
now I just need to like check for any dupes. That's what I'm guessing. After that,
Yeah.
I fixed the
Yeah,
null
if-
thing.
You check if it already exists there. And if it doesn't, you need to make a new node and like put that character in the right spot. If it does already exist, then you're just changing your pointer.
So I would use the current pointer dot next or just
Yeah.
I guess. Yeah.
Hear me?
Yes.
Yeah, we can hear you.
Thank God. Okay.
I thought you were on mine for a second there.
I actually only had one question. I know. I was like, how am I going to pose my question? But the question I had was the
Strange.
and it said, if there's an input n for the toString, and then you get completions. And then it said if you have more than what is the n, I guess you put ... at the end. But then I got confused. The n is the limit, so when you get the return size of the get completions, it's going to be the limit. So how do you know if it's more
Yep.
than the? That's my only question.
Yeah. No, I had the same. I was like, this doesn't make any sense.
It
Like,
doesn't
what
make
is
any
limit
sense.
supposed to be doing? I just passed, as far as the size, the limit that I passed in,
Yeah.
to when I called get completions, I passed it limit +1.
Yeah, I was thinking that too. I was doing limit. I was thinking that too. Yeah, because
Yeah.
sometimes it passes, sometimes it doesn't, and so
Yeah.
so it's not really foolproof right now. But it passes now. I'm not going to submit it again because it's going to fail the next time probably.
Yeah, eventually I changed it to like vectors have a max size method that you can call. So I did change it to that, but really you just need to check if there's at least one more
One more than the
completion. Yeah.
Okay.
On that, yeah,
right.
on that drawing quest that we did before, I did pass one of the mini quests, even though I failed all the other times. So yeah, it was just because it was like drawing in one direction, and that's why I passed. Like sometimes that happens.
Yeah, it's
Sometimes
not
you might
foolproof.
test because it like he just doesn't search for like the discrepancies. Yeah. It looks like I just need to look for dupes now.
And that's the last mini quest, right, Shirley?
Yeah, the sort
Oh, toString. That's what I was
toString.
asking.
No, well, it's one of the last ones. It's after you get the password, then
Mhm.
you do the toString and then the sort. So
I tried doing like the last quest two string, but I kinda like I don't know, it was weird.
oh,
I tried following the spec, but it was just like even though it looked right, I don't know what I did wrong. So yeah. It was
Yeah, on a
weird.
lot of these, I've had to put them into diff checker to see if there's like some small difference between them that I can't see.
Yeah.
Sometimes there's like an extra space or like there's one line that's missing or something like
Yeah, I
that.
just ended up like copying the text inside like the um thing, like the text that the teacher gives us,
Mhm.
and still didn't seem to change a thing. So yeah, it can be a bit finicky. Yeah, the shoestring, some of them are kind of strange.
Yeah. Well, I don't really have anything to ask because I haven't really started anything yet. So
so you've done 2C a little bit, right, Dylan? A little. You try to get into
no, I've done
this?
I've
Oh,
done a different 2B.
I see.
I
I
think
thought you
that
did
must have been
2C.
Jonathan or someone else. I don't know.
Okay.
Someone else who want is taking this class because they couldn't handle 2C. I don't know.
Okay.
Yeah, I'm bummed to hear that he's not doing 2C because I do feel like I've learned a lot from this style, but I guess like he's saying, we can just sort of keep doing it. What are your guys' plans as far as, or were you planning on doing 2C or anything?
I just
I'm
need
gonna
more
transfer.
practice. It's a way to practice. I mean, I don't know
Yeah,
how it's going to be without meetings or whatever. It's because the spec is so vague, and you're just you're guessing, and it takes a lot of my time. Maybe it's short for you guys, but it
Yeah.
takes a lot of my time trying to figure it out. And so I don't know, but it's my only way to practice, I guess, for the summer.
Mm.
I'll try to continue, but until the fall.
yeah,
I've been like mostly just focusing on like my math class actually.
Oh,
So yeah. Like
which
this
math are you
class,
taking?
It's 1C.
Oh, okay.
Yeah. It's just like a lot of work at this point. Like I've had to do like 50 problems in one night.
What
That's
class is
crazy.
that?
Math 1C.
Like, what do you actually, like, what's the like learning in the course?
So at least with the teacher I'm taking, it's like you have these worksheets and then you do it online. Like the actual stuff that's been graded is being done online on a website called Edfinity. It's a pretty useful website. And you do all the it's where you're actually graded. You're not graded on the worksheets, though they're still important. They're relevant to the material. They show you how to do things. And then Fancy shows you how to do things. And then eventually, you take your question, your quizzes and your tests on Edfinity. So
Hmm.
yeah.
Yeah, I was just curious. I'm taking linear algebra right now, so.
Yeah. So the funny thing
Nice.
is like in
Oh,
terms
man.
of what would you call it? Chronicle chronology in the book. You're doing like what comes before in the book at the end because it's so intimidating. Like, so I'm doing that right now, and it's like, oh look, so many like tray long summations. Might as well use my calculator. Basically, like sequences and series at the
Oh
end.
man. I have to do so much math. Like I've been working in the film industry for like many years now, and I have not used math like since getting out of high school, basically.
Right. Right.
And so now I'm like trying to get into computer science, and I'm just like all of these computer science grads, like they're having to take all these math classes and shit. Like
Yikes.
I know I have to take discrete mathematics at some point. That's the only one I've really heard that you definitely have to take, but it's so daunting.
Yeah.
Like just hearing you talk about this stuff is making me anxious.
Yeah, I just finished discrete math there at Foothill. Really interesting stuff.
Oh, how is it?
It's challenging. It's challenging. But I have to admit it's really interesting stuff. I mean, things that you never thought of. I mean, you would do a math problem and you'd get your answer right away. But then this one actually makes you think, and it makes you really understand how do you prove that a number's even? Just those simple you have to create your proof, how to write the
So
proof and everything. Teacher was pretty good. He was very strict on, okay, this is how you write your proof, the wording and everything. What you got to know your theorems, you got to know your all those
So are you like
rules and
saying
whatever.
that this is a philosophy class disguised as a math class?
But it helps with your computer science and all that. I mean, Hanoi goes in, Hanoi is explored, all these other stuff. So, but yeah, prove an even number, prove that it's odd.
That's crazy.
Yeah.
No, it was crazy. I took it last quarter, like
Yeah.
my school.
You took the
quarter,
linear
but-
algebra. I was like wondering if you did discrete math. Actually, it's like I think you did already.
No, it's crazy. We went to like graphs theory at the end of it, so it's like.
Yeah. So I think it's pretty cool though. I liked it. It's challenging, but I liked it. So,
Yeah, I've been working through Khan Academy.
Yeah. Khan Academy is
just like
awesome.
just to like get myself up to a level where I can actually apply for these classes. Because I was like, I took this thing that was like, just like, how much math do you know?
Yeah.
And I was like, back in like geometry, like middle school level math.
Yep.
It's like,
Oh yeah. Yeah.
I
It's
don't
years
like
ago.
geometry.
yeah, so I've just been like, well, I haven't really, because I've been, this class has taken up a lot of time, but I need to get back on that because I know I need to take those at some point. Next semester during summer, I'm just taking a Java, intro to Java class that are
Yeah.
That's another pretty popular
Good luck on
language.
1B and 1C on that. At the
Oh,
end of
really?
like 1B, like there's only like I guess like 10 people in the class, while in the beginning it was like full of people. That's what I remember.
Oh man. Well, I feel like it couldn't be any harder than this.
I enjoy Java actually. I mean, I'm not great at it, but I actually like it. I like it. It's nice versus pointers. So,
But it's nice to know the harder side of things, I think. You know, the inner workings of like
Yeah.
what Java is probably doing under the hood.
right, right, exactly. Yeah.
Yeah.
Well, yeah, it kind of sucks he's not doing 2C, but I guess maybe we can all just sort of keep in touch and maybe sort of pursue it together or something like that. Because
Advice on
yeah,
Reddit.
I know it's hard to do this stuff like by yourself.
It,
It's really
I'll
been
be like
helpful to have these
transferring to a different
meetings.
college. So I think I'll have my hands on something else. Or something else.
Where are you transferring?
I decided Chico, more like out in the country, that sort of thing. Yeah.
let's see.
Yeah, but
All
I was
right.
planning on doing the red quest during summer, so I'll be on the
Okay.
Reddit if anyone else is gonna be there too.
Yeah.
Right quest Reddit.
I'll attempt it. So,
Yeah. Fun quest.
we'll see. All
All
right.
right, I'm
Hey,
gonna
thanks.
hop off and start working on this.
All right. Have a good
Right.
weekend.
See you
See
guys.
Good
ya.
luck, bye.
Bye.
Bye.